Hello everyone, welcome to Maths Easy. Here is another possible exam style question for A-level physics. It's on electricity again. Three identical batteries, each with internal resistance lowercase r, are connected in series with an external resistor, right, of resistance capital R. The current in the external resistor is capital I. Now, if two of the batteries are reversed in the circuit, what's the new current in the external circuit, external resistor? So you can give this in terms of capital I. So first, let's draw a diagram to show the situation. So here you can see the circuit diagram. Three identical batteries, each with internal resistance lowercase r, are connected in series with an external resistor of resistance capital R. Current is marked, and then they're talking about the change that you're going to do here, right? The question says batteries. I just drew 3 cells, but it really doesn't affect the question. So let's give it a try. Now, can you please pause the video and work it out yourself? And when you're ready for the answer, you can press play. Now, I just did a diagram on the right hand side to show the change. So how this is different, right? Now, in the first circuit, you can clearly see all of these three batteries or cells are pushing the current to the left away from the positive. Here, this one is pushing that way, but the other two are pushing in the opposite direction now. So this is what makes it different. Now, in terms of resistance, the resistors, there is no direction to the resistors. So all of these internal resistors and the external one, they don't really change. So let's write the equation. I is equal to E over R plus R for the first circuit. So current I is equal to EMF 3E, because there are 3 E's here, over the total resistance is, they are all in series, capital R plus 3 lowercase r's. Let's call this equation 1. Now let's do the same thing for this one. Now in this one, let's call the current I dash. It's a different current, I dash. So I dash is equal to E. Now this first one is pushing that way, the other one is pushing the other way. So these two gets literally cancelled out, the EMFs. So the only EMF now is that way. Oh, now the implication of that is the current will now reverse the direction. The current will go the other way. Why? Because these two cancel out, and the other one is now pushing the opposite direction. Okay. So I dash is equal to E over, what is the total resistance now? Well, still the same. R plus 3R2. Now, to do this one, to find the current, all I need to do is just simplify them. So in a question like this, the easiest way to simplify them is just divide one by the other. So let's do that. So I'm going to divide 2 by 1. So I get I dash over I is equal to, I dash is E over R plus 3R divided by this. I'm going to turn it into multiplication and take the reciprocal. R plus 3R at the top, 3E at the bottom. Now this and this completely gets cancelled out. E and E gets cancelled out. So I dash, the new current, is 1/3 of I over 3.